Hey everybody, Mr. Smith here. In this video, we are going to keep talking about different types of quadratic equations and how we can write them. In the last couple of videos, we talked about vertex form of a quadratic, and we talked about standard form of quadratic. And in this video, we're going to talk about the third type of quadratic equation, which we're going to call intercept form. All right, so let's dive right in, and I'll tell you about intercept form of a quadratic. It looks like this: y equals a times x minus p times x minus q. That's the general form of intercept form of the quadratic. A couple things here to know. A still tells us whether or not you have a stretch, a shrink, or a reflection. So your leading coefficient still accomplishes all those things. It either stretches it, shrinks it, or flips it upside down. The reason why we call this intercept form is because it's really easy to find the x-intercepts of your function by looking at this equation. All you need to do to find your x-intercepts is look at p and q, which we label as the numbers inside of the parentheses, and those two numbers individually give you your x-intercepts. There are two of them, right? There's one x-intercept here. There's one x-intercept here on most parabolas. So you get two x-intercepts by looking at p and q. One of them is p, one of them is q, and we write them like this: p0 and q0. Notice how we flipped the sign. Okay, just like we had to do that in vertex form, we're still going to do that here in intercept form as well. All right. So you look at p, you change the number, that gives you an x-intercept. You look at q, you flip the sign, that gives you another x-intercept. All right. In order to find the vertex, we have to think about the fact that a parabola is symmetric, right? So a parabola is symmetric, right, on the vertex, and that occurs halfway in between these two x-intercepts, exactly halfway in between them. So that means in order to find the axis of symmetry, all we need to do is take the average of my x-intercepts, which simply put means we're going to use this equation. X equals p plus q over 2. That is the equation to find the axis of symmetry when we're in intercept form. Right? It's just halfway in between the two x-intercepts. To find the second half of the vertex, it's going to be the same way that we did standard form. We're going to take the axis of symmetry, plug it back into the equation to find the y-coordinate. So let me show you an example of how this is all going to come together. Here is an equation in intercept form. I know it's in intercept form because it's factored. It has two things being multiplied together in parentheses. Okay, so it looks like it's in intercept form. So first, before we do anything, we can find the x-intercepts of this graph very easily, right? All I need to do is look at p and q, the numbers inside the parentheses, and flip their signs. So one of the x-intercepts is going to be negative 1, 0. I get that by looking at 1 and making it negative. The other one is going to be negative 5, 0. Get that by looking at 5 and making it negative, right? So those are my two x-intercepts. Okay? Now that I have my x-intercepts, let's find the vertex and the axis of symmetry. So first, we need to use this equation from up here, right? P plus q over 2. That's going to give me my axis of symmetry. So let's think about that. I'm going to find my axis of symmetry. X equals p plus q over 2. Well, p and q are negative 1 and negative 5. Right? Notice how I'm taking the x-intercepts and not the numbers that I see in the parentheses. I'm taking the actual numbers for the x-intercept. I'm plugging them into this equation. So it's negative 1 plus negative 5 over 2. And if we simplify this down a little bit, negative 1 plus negative 5 is going to give me a negative 6 over 2, which gets me a negative 3. So that's my axis of symmetry. That's the line that cuts the parabola in half. But we're not quite done yet. We still want to find the vertex. Remember, vertex is the most important point of a parabola. We always want to find it. So to get the vertex, it's just like we were in standard form. I'm going to take the axis of symmetry, which I found right here. I'm going to plug it back into my original equation. My original equation is y equals negative x plus 1 times x plus 5. Okay, and I am plugging in x equals negative 3. All right, so I'm going to replace x with a negative 3 because that's the axis of symmetry that I found. So let's see what it ends up being. Y equals negative. X becomes a negative 3. X becomes a negative 3. And now I just need to simplify this. So we think orders of operations. We always take care of what's inside of parentheses first. That negative sign in front hasn't changed at all. Haven't touched that yet. Negative 3 plus 1 gets me negative 2. And negative 3 plus 5 gets me positive 2. So let's keep simplifying this. Let's do multiplication next. Negative 2 times positive 2. Negative times positive is a negative. So it's negative 2 here, but I still have that negative sign in front, right? So negative sign didn't change. Or sorry, negative 4 I meant to say. Negative sign didn't change in front. Negative 2 times positive 2 is negative 4. And now that I have a double negative, I can simplify that to end. Negative 4 is the same thing as positive 4. All right, so there's the y coordinate for the vertex. That means that my vertex is the point x coordinate negative 3. So that's my axis of symmetry, and the y coordinate is 4. So there is my vertex, most important point of a parabola. Okay? Let's say I want to go graph this thing now. All right, so before, when we graphed vertex form and standard form, we used a table, right? We had to build a table, plug in points, and go from there. When we are in intercept form, we do not need a table. We do not need a table in intercept form. Okay, that's one of the nice things about intercept form. We don't need a table. We have everything we need to graph it right now. We have our two x-intercepts, and we have our vertex. So I'm going to go plot all of those points. So first, let's plot the x-intercepts. So negative 1, 0, and negative 5, 0. And my vertex is negative 3, 4. So it's negative 3, back 3, up 4. Okay? So I've plotted all my points. And now, look at this. I can see the parabola coming together, right? I'm just going to connect these dots to create a parabola. And there it is. I'm all done. And this also makes sense that it's going upside down. It's opening down because I have a negative sign in front of it. That tells me that my graph should be opening down because it's a sad parabola. All right? Let's do two more examples here, and that'll do it for this video. So let's look at this one. Here's my equation, 2 times x minus 3 times x plus 1. So again, to find the x-intercepts, all I do, look at these numbers inside of the parentheses and change the signs. So one of them is going to be 3, 0, and one of them is going to be negative 1, 0. Okay? So there are my x-intercepts. Let's think about the axis of symmetry. I'm using this equation, x equals p plus q over 2. P and q are right here, 3 and negative 1. So it's going to be 3 plus negative 1 over 2. Well, 3 plus negative 1, that's the same thing as 3 minus 1, right? So that is 2 over 2. And 2 over 2 simplified is just 1. So there's my axis of symmetry. Now to find the vertex, I'm going to take that axis of symmetry and plug it back into my original equation. So my original equation is y equals 2 times x minus 3 times x plus 1. I'm going to plug in 1 for x in both cases. It's going to be 2 times 1 minus 3 times 1 plus 1. Think orders of operations. Parentheses come first. So I have y equals 2 times 1 minus 3 is negative 2. And 1 plus 1 is 2. Now we just got to multiply this. 2 times negative 2 times 2. Let's think about it like this. 2 times negative 2, we'll do one piece at a time. 2 times negative 2 is negative 4. And negative 4 times 2 is negative 8. Chunk it up a little bit and do it one piece at a time. So that means that my vertex is the point with x 1 and y negative 8. There's my vertex. Okay? All right, so to graph this thing, remember, we have everything we need. We've got two x-intercepts, and we've got a vertex. Let's go graph all those things. All right, 3, 0, -1, 0, and my vertex is at 1, -8. So I'm over at 1, and I'm down at -8, right there. And then I'm just going to draw my parabola as accurately as I can. There we go. There's my quadratic equation in intercept form. Okay, notice how I didn't use the table, just connected the points. All right, let's talk about domain and range on this one. We're going to keep coming back to this idea a little bit. Domain, remember, that's my x values. That's all the x values where my function exists. So I'm reading right and left, asking myself, does the function ever stop? The answer is no. It goes forever in both directions. So my domain is all the real numbers. Okay. And what about the range? Remember, the range is going up and down. So I'm reading the graph up and down, and I'm asking myself, does the graph ever stop going up and down? And the answer is yes, right? If I start up and I'm reading down this line, I eventually get cut off here at y equals -8. Okay, that's where I get cut off. So that's going to be the end of my range. I'm going to write that as an inequality. I need all the y values that are above that cutoff line. All the y values that are above y equals -8. So I need y's that are greater than or equal to -8. There's my domain and range. Okay, one more example for this video, and we'll wrap it up. So I'll have another equation, 3x times x minus 4. And this one looks a little bit different. Before, all of our equations had 2 sets of parentheses. Now we only have 1. Okay, so what does that mean? Does that mean we're out of luck? Does this mean this problem's impossible? No, it doesn't mean that. We can still solve this problem. I'm going to rewrite this equation in order to look like this. So if you see a problem that looks like this one right here, don't freak out. That's okay. You can just rewrite it to look like this. Y equals, I'm going to show you what I'm going to do. 3 is in front. And if I just write it like this, turn that x into an x minus 0, now it looks like it's in intercept form. X minus 0 and x are exactly the same thing, right? I didn't change the equation at all. I just rewrote it, so now it looks like it's in intercept form. Okay? And actually, I'm going to cut this video off now, so it's not any longer than it needs to be. From here on out, you would finish this problem the same way we did the other one. You get your intercepts right here. Look at the 2 numbers. It'll be a little bit different because this one has an intercept of 0, 0, right? That's okay. Totally fine. You get an intercept of 0 from your first term. Look at that number. Flip the sign. It'll be 4, 0. Those would be your 2 intercepts. When you find your axis of symmetry, p plus q over 2, use these numbers, right? So it'd be 0 plus 4 over 2, which would be 4 over 2, which simplifies to be 2. So there's your axis of symmetry. And then from there, you would just solve this problem out, just like we did the other ones. You take this number, 2, you plug it back into your equation. That gives you your vertex, and then you're ready to graph. Okay? So that's going to do it for this video, guys. Thank you for watching. As always, feel free to email me if you have any questions, and we will see you guys next time.